This week, let's take the top questions of our how-to section. Alright, so let's take a look, and the first thing we got here is how to use signals. Alright, well that'll be simple enough for us to quickly go over. Just bring up our section here. So we can take a look here, and if you want to use a signal, of course you have to connect it. So different ways that you can do that is you can just select your node from your hierarchy on the left hand side. Select node on the right tab. Of course, these are the default positions right beside the inspector there, and you'll see all the signals that are possible from that specific node or object. Now you can go ahead and you can change this at any point, or you can of course set any of these. So we can do text change, and that'll be in this case of a text edit, anytime the text changes. So that includes anytime you type anything into this. Alternatively, what we could do is we could do breakpoint for an easy one for this, but let's go ahead with text change. Alright, so with text change, you go ahead and select your signal. You go ahead and select the node that has a script on it that you want to connect it to. Hit connect. And now down here at the bottom, I'm just gonna this. I know there's an option, so I don't have to do that, but I don't mind. So now we have this little icon here next to my line 60 telling me that this is a connected signal. So when the text changes, we can do something. And what we're going to do is we're just going to print text change. That's all we're going to do. So if we go ahead and run this and you take a look at the output there, every time I type something, you can see that signal is being sent out. And once it's received, we're printing out to our console text changed. And that, of course, works with spaces, tabs, enters, all of that. Great fun stuff. Now, that is the easiest way to, of course, connect your signal. But there are manual ways that you can connect it. For example, up in our ready function here, what we could do is, in the current form that the engine is at 3.4, with this version of the language, we would just get what we want. So in this case, we're going to get that text edit, which is ourself in this case. So I'm going to say self because that's what my script is. We call the connect function. And our first input is the signal that we want to call. So in our case, we're going to look for text change. The second argument is what you want to attach that script to. So what script has that function on it. If you remember, if we go over here, and if I were to go like this, whatever you would have selected here, that's what goes to our second argument. So since we selected the what I'm calling the code editor, which is a text edit, the same thing that's sending this signal, I'm also going to say self. And our last argument is just whatever you want your function to be named in the form of a string. So if we just go like this, and I disconnect that, this should now work exactly the same. We just connected it manually. And there you go. Still works. Now in 4.0, when we have GDScript 2.0, this will be changing slightly on how it gets used. So maybe we'll do an update when that comes out. Alright, let's take a look at our next question. Let's take a look at the next question. How to use blank? Well, I can't really answer that question. Let's see, how to use C#. Okay. It's not so much GDScript related, but if you really want to use C#, we're going to head on over to the engine website. We're going to go into our download section. And you're going to download the mono version. And once that's completed, you can also use an external IDE, which is normally preferred by the majority that are going to use C#. But all you have to do is download the C# version like we're doing here, and you're going to run it just like normal. Now, the only difference that we're going to see here is when you go to add a script, you'll then have a C# option listed here in your language. And you can simply select that and start editing it inside of the editor here, just like normal. However, if you want to use a different IDE, I just search external. So this inside of the editor settings, we go to text editor section and external. You can see you can use external editor. You can turn that on, and then you can go ahead and browse for the editor or the IDE that you want to use. So if you want to use Visual Studio Code, you can go ahead and locate that executable, and then whenever you have your script here, so if you were to click on the script button here, just like it opens up in here for me, if you have the external editor on and something selected, it'll open up that program and open this, or open that script inside of it. Alright, so that's how we can use C#. Let's see what we got next. Let's see what do we have next. How to use a sprite sheet. Okay. Sprite sheet's fairly simple. I've gone ahead and I've got my kangaroo sprite sheet here. It's got a couple different animations. We got an idle on top, and we got a jumping animation at the bottom. So on the assumption that we can say this is a player, for example, let's go ahead. We'll have our kinematic body, and instead of using an animated sprite, we're just going to use a normal sprite. And we're going to use the entire sheet, in as the texture, like so. I'm just going to quickly remove the filter. We can re-import that. Go. So you might be looking at this and you're saying you only want to use one section of this sprite sheet, right? You only show one item or one frame of this. Well, that's where we can go into the animation section here, and we can tell how many horizontal frames, which is left and right, and how many vertical frames there are, which is up and down. So if we take a look, we got 3 frames going from left to right, and we got 2 frames going up to down, or bottom top. So I'm going to say 3 on the horizontal and 2 on the vertical, and there we go. We now have our frame. So all we would do now is we would have our animation layer, just like with any animation. Go ahead and create yourself a new one. We'll say jump. And all you're going to do, instead of pulling or dragging a bunch of different sprites in, all we're going to do is we're going to go into our sprite, and we can just keyframe our actual animation here. So I'm going to go to 3. I'm going to set that as a frame. Then we're going to go ahead to, let's go 0.2. I'm going to increase this to frame 4. Oh. Go 4. And we'll go to 5. And now if we were to play this with a loop, of course, we can take a look and we can see we got our animation starting, right? And in this case, you can loop because he's just doing a little jump there. And this will work better if we actually cut this down to something like 0.5. There we go. And now you can see we're using our animated sprite, or we're using our sprite sheet for creating an animation for this. Now, of course, if we just wanted this to be an object in our scene, just of course like a static object, then we can of course just create a sprite, bring our sprite sheet in that's maybe got a bunch of different objects on it, come in, we'll tell it 3, 2, and now we can come in and we'll say this is one item, this is another item, and this item maybe is on this frame, right? So you can do that if you just want to have a bunch of different items together in one sprite sheet, right? So you can have like maybe a sword here and a shield here, but you have them together as one sprite sheet in order to save a bit of space and room to keep your total project size down. But that's how you use a sprite sheet for if you just want to have a bunch of objects in there, or if you want to use it for a character sprite sheet for your animation. All right, let's go ahead. Let's see, what do we have next? We've got a timer. Is that right? Yep, that's a timer. All right. All right, so to use a timer, you can basically go ahead and just create a timer node. So, and add it into your scene. And over on the right-hand side, you'll see a property called wait time. Now, wait time is basically how long the timer is going to last. And until, of course, that timer hits 0, right? It's going to be effectively counting down, counting up, however you want to think of it. We also have a property called one shot, means the timer's only going to run one time. And we have auto start, which of course means the timer is going to automatically start as soon as the scene here loads. Now, depending on what you're doing, you may want that on or off. I'm going to turn that on. Now, for your timer, if you're not going to have the auto start going, then somewhere inside of your code, you're going to have to get your timer node, and you'll have to call the start function on it. Like so. But since I'm using auto start, I don't have to worry about that. And to show off the timer signal, how we're actually going to use this, we're going to connect the timeout signal. You can do this manually if you wanted. It's perfectly fine. And I'm going to set this to work with a label. I'm going to put this label just in the middle of my screen. And you can see when our timer ends and hits 0, I'm going to add 1 to a variable I called num, and I'm going to change the text. So since my wait time is every 1 second, we're going to see this label change every second consistently. As you see here, it's going to count up for us. So you can use these timers to wait for something, or to trigger something to happen, or to have something happen repeatedly on a set timer, or on a set time difference. These are essentially different ways that we're going to use the timer, and the other way that you could use it is kind of merging it with yield, which we're going to, of course, touch on in just a little bit. But to use it there, we're basically just going to pass in 2 arguments to our yield, which is going to be getTree and createTimer. The number that you put in here, where I have my 5, is your wait time. And then the second argument is a signal that you're waiting for, which is the timeout. So in this situation, using the yield, we're basically going to wait this amount of time. When our timer finishes, then we continue code. So those are 2 different ways that you can use a timer within your code. Based on your situation, will determine which style is best. Let's see. Next up, we have shaders. Let's go ahead and make this real quick. Any shader that you want to incorporate, let's go ahead and delete those. The simplest form of doing that, of course, we can do it inside of a 2D. Go ahead, add a sprite to it. So we can go on down to our material, and you got shader material, and you have a canvas item material in this situation. If you were to go to a shader material, you can open that up, and you can select a new shader or a new visual shader. A visual shader is going to have your nodes here. So if you're more comfortable with working with a graph system there, such as with Blender, that may be what you prefer. Otherwise, you're going to select new shader and you open that up and you're going to write shader code here. Now, this is its own language and it's a whole different topic of its own. Alternatively, if I just open up a, select don't save there. Alternatively, if we just open up a 3D scene, you do a mesh, we'll go ahead and we'll just say cube. There we go. So we have our little box here, and in the case of something 3D like this, you're gonna have a shader material and a spatial material. A spatial material is basically a shader material that we looked at with the code, except it is going to have a simpler form for yourself. So we basically have all this stuff written out for us by default that we can change. For example, if we change this to red, it's now going to become more of a red. Same if we go to greens and all that. And if you're curious in the future how some of this stuff starts working, we can select in the top right corner this one of these sections. Oh, there it is. Alright, so we can just select the drop down there for the material, and we could choose convert to shader material. And then if you're curious on that now, if you open up that shader, you can see this is all the code that created the shader that you made. Just using the visual there. So if you're ever curious on the one-to-one, or you want to see exactly what yours is like, that's all it is. So you see the albedo is, we're getting the RGB, and we're multiplying that by the RGB of our texture, essentially. But there you go, that's the basics of how we start getting into shaders without actually covering the shader language itself, which is a lot more complex and requires a lot more time. Next up, we have yield and tile map. Alright, well, we already touched on yield a bit with timers. But the thing that we're going to do here is, if you want to wait for a function to complete and then continue on, for example, we're going to use this math function here. You're going to go in and you need a completed signal to emit from that function. So outside of my for loop here, I'm just going to go ahead, and the easiest way to do that is to call yield and pass in the first argument of getTree and the second argument of just waiting for an idle frame. Now, as soon as we get an idle frame, that's going to send the completed signal, and that's what we're waiting for. So wherever it is that you want to wait for that function to complete, in my case again, math, I'm just going to call yield, and my first argument is going to be math, because that's our function that we want to wait for. And then we're going to wait for that completed signal. And you'll see, in this case, once my signal has been passed through, we're going to wait for the math function here. Once that's done, I'm going to change the word func in my little editor to aqua. So if we take a look, and I write func, you can see it's just this gray color, and as soon as our function is complete, we'll continue on and we're going to change the color of it. Oh, there we go. We just didn't have our spaces in there. So let's do that again, just to show that off. There we go. We can take a look, and as soon as it's done, our color changes. So that's how you can use yield to wait for a function to complete. And you saw earlier when we were looking at timers briefly, how we can use yield kind of mixed with a timer to tell our program to wait for a set amount of time. And let's see, camera 2D, there's not much to really use it. It's kind of tweak the properties. Delta, we kind of covered that already in our when to use section, I believe it was. And alright, tile maps. how to use a tile map. Well, the easiest section, or the easiest way to tell you that, but the easiest way to go over that, we have tile sheet here that we want to use, and what we're going to do is we're actually going to add a tile map node to our scene. We're going to go to the right hand side, go into our tile set, get a new one, open that up. Now we're just going to drag our tile set into this open space at the bottom left. Right. Now inside of this is our tile sheet editor. We can select new single tile. You have the option of using the snap option. And you just go ahead and drag. And you go ahead, select new single tile. And you can just continue on this path to create all the tiles you want out of your sprite sheet. And if you take a look at the top there, if you create your tile, you see you can also set the collision, the occlusion, and navigation options there. Perfectly fine to use. But once you've got that all set up, just select your tile map again, and you can see all your tiles are here to use. And it's that easy to get started with using tile maps inside of the engine here. And of course, you have a few options here on the side that you can tweak, like your cell size. I'll set it 64 by 64. Maybe we go 32 by 32. And obviously, that's not the right size for this specific tile map. So you can tweak around with that. And of course, you got the transform position, scale, and all that stuff that you can tweak. But that'll do it. That covers our how-to section, or how to use